Can you hear me now?
Yep, now you sound great.
Okay. This is the first day we've had technical difficulty, so I think we should count ourselves lucky. So I want to thank everyone for registering for our Protect Pikas Day of Colorado Endangered Species Week. We have a whole suite of events going on this week, so I'll be dropping the link in the chat to get hooked up with the rest of them. But before we begin today's, I wanted to give a land acknowledgement and a land back statement. I'm an Indigenous individual by way of Canada, but I'm a settler on these lands. The Colorado Pika Project takes place on the ancestral and traditional lands of the Cheyenne, Arapaho, Ute, Eastern Shoshone, Jicarilla, Apache, and Oshedishakawian people. In offering this land acknowledgement, I ask us to recognize the state-sanctioned acts of genocide, displacement, and dispossession against the original and rightful inhabitants of this area, and the challenges that Indigenous communities face today as a result of past and current colonization. I also want to respectfully acknowledge the generations of stolen and enslaved Black people and their descendants who built and continue to build this country that we now occupy, as well as the violent history of US colonization and imperialism that has displaced generations of people from their ancestral lands abroad. I also want to recognize the long-standing systemic racism, including economic and environmental injustice, which has created conditions that continue to disproportionately impact marginalized communities across Colorado and beyond. As a first step towards accountability and reconciliation, I ask that we commit to knowing this history and honoring our collective ancestors who stewarded the land and protected the species native to it long before we came. I ask that we collectively learn to respect, trust, and affirm Indigenous sovereignty, history, knowledge, and experiences, and pledge to support the land back movement and reparations in any way that we can until such time that the land is ceded to its rightful stewards and all marginalized communities are treated equitably with justice at the forefront. And just like American pikas won't be helped by simply acknowledging the threats that they face, we need to take action. So I ask if anyone has any meaningful action that you're aware of to drop that in the chat so that everyone can take action. And I will be sharing today an action to support the Cheyenne and Arapaho tribes' proposal to rename Mount Evans to Mount Blue Sky. So I'll be dropping that in the chat in a little bit. I also ask that folks with means, if you have means to support Spirit of the Sun, it's a local Indigenous nonprofit. Spirit of the Sun recognizes that climate justice, environmental justice, and racial justice are not separate from each other, but that the fight for one is the fight for all three. So please support their programming with a donation today if you have the ability to do so. So with that, let's get into our program today. We're going to start with some introductions. So my name is Chris Talbot Heindel. My pronouns are they, them. I'm the Communications and Membership Manager at Rocky Mountain Wild. And I'm going to briefly describe myself for people with low or no vision or those of you on the phone. I'm a light-skinned, multiracial person with tons of freckles. I have shoulder length, salt and pepper hair. I'm wearing a navy shirt today, and I've got a shoji screen in my background. I will pass it to Megan.
Hi, I'm Megan Mueller. I'm Senior Conservation Biologist with Rocky Mountain Wild. I use she, her pronouns, and I am kind of a middle-aged person with some gray hair and big smile. I'll pass it on to Peter.
Hi there, my name is Peter Billman. My pronouns are he, him. I am a 28-year-old male. I'm a graduate student here at the University of Connecticut. I have short, dark brown hair. And yeah.
So before we get started, I wanted to point people to a couple things on your Zoom screen. So at the very bottom, there's a link for a live transcript. And if you need that as a resource, feel free to click on it. It won't be accurate. I've learned over time that these computers don't understand what a pika is. So you'll get all kinds of different items instead of pika, but it'll help. There's also reactions at the bottom if you want to react to anything. I already saw someone dropped in a heart, so Feel free to react. And if you have any questions as we're going through, we're going to save them for the end, but go ahead and drop them in the chat if you want. Otherwise, we'll be asking folks who feel comfortable. You can come off mic when we're in our question and answer portion and ask your question live if you prefer. So with that, I will hand it over to Peter.
Alrighty. Before I get started, I want to apologize as I am positive for COVID once again for a third time here. So I'm a bit stuffy, so I apologize for the sniffling throughout today's talk. But let's hop into it. Let's see. All right, can everybody see that? I guess can Megan and Chris see that? Okay, perfect. Okay. So getting into it. So what my research kind of focuses on here is the distributional effects of climate change on American pikas. This presentation is going to primarily focus on my master's research, which is up in Montana and Idaho. I'm up in the Northern Rockies there. And so with that said, I'm going to hop straight into it. Although I guess I should acknowledge that that research was at Montana State University. Now I'm at the University of Connecticut. And this is going to relate to some of my PhD work here coming up in the next year. And so getting into it, as this GIF here kind of shows, what changed with climate change is we don't notice these small increases in temperatures. However, we do notice these large increases in these climatic extremes. So we're seeing a lot more heat waves, we're seeing a lot more droughts, we're seeing a lot more large rainfall events, things like that. And so as climate change seems to culminate, we're seeing these large changes in different extremes, I guess I would say. We're seeing less cold extremes and more heat extremes. Colorado knows that firsthand. You guys are getting fires, it seems like, year round now. And so I don't need to kind of beat a dead horse with that. But this figure kind of shows nicely. This is a glacier national park. The white here represents some glaciers. And this extends back from 1910 or the late 1800s and shows as these glaciers are melting and receding upwards, we see different types of vegetation are moving upward. This gets to 2000, 2010, 2020. And as you can see, there's this rapid increase in both grasslands and sagebrush steppe moving uphill. And so as vegetation moves upslope to track climatic conditions, as we see climate change, we can expect animals to follow suit. I'll let it go through this one more time. It's just a very, very neat figure showing kind of how these things track climate very closely. Now, we know that animals track vegetation, their food sources pretty closely. And so we can expect them to do generally the same pattern, maybe with a bit of a lag. Okay, so what are pikas? Why do we study them? I think most folks here are probably familiar with pikas already a little bit, but for those who are not, these are pikas. The guy on the right is a pika in the middle of winter. They get really, really round. They get a lot of fat storage, but they also do this to conserve heat in the winter time. The guy on the left is eating a little columbine flower. Okay, so pikas. Pikas are not just a species that's found in the Northern Rockies. It's not found in the Southern Rockies. They are found throughout the world. And so there are two different species in North America. I guess you can't see my mouse. Okay, so up in the left, we see that there's a species up in Alaska and Canada, and then we see another species in the Western United States and Canada. And so the American pike is the lower one, and the collared pike is the one that lives up in Alaska and Canada there. And so today I'm just gonna be focusing primarily on the American pika. But as you can see with the green on the right side of this map here, the pikas are found all throughout Asia, everywhere from Russia down to China and northern India, all over the place, Pakistan. They are found in mountainous regions as well as sagebrush steppe regions and meadows across the northern hemisphere here. And so as of today, there are about 34 different species across the planet. There used to be many, many more, however, many went extinct. There actually used to be some here in the eastern United States millions of years ago. And so pikas first appeared, evolutionarily speaking, about 16.4 million years ago, so quite a long time ago. However, they didn't make it to North America until about 8.9 million years ago. They were very heavily distributed across both Asia and Europe there, as you can see. Or actually, I guess you can't see because they no longer occupy Europe, but they used to be quite widespread across Eurasia. So the American pike and the collared pika here in North America then went on to split about 4.1 million years ago. So again, relatively recently. And so they do not touch each other. As you can see, there's quite a large gap there. There's some mountainous, there's some gaps in the mountains up there where pikas do not occupy whatsoever. And so the split was pretty recent. And just as for our own reference, hominids came about 3 to 2.5 million years ago. So pikas versus American pikas versus collared pikas are just a little bit older than hominids are. So getting into the American pika, this figure kind of ignores the Canadian subspecies up there, but just focusing on the Western United States here. Let me see if I can move this. I'm not sure you guys can see that. Okay. So the American pika, Ochitona princeps, it actually translates to little chief hare, which is quite a cute little name. They're found pretty widespread throughout the mountains of the Western United States, with some exceptions in the Great Basin and the Olympic Peninsula and Arizona. And so they're found throughout every other Western state except for Arizona. They're listed as a species of conservation concern in each of these states except for Montana and Idaho, which actually now looking into listing them. But as you can see, they're pretty tightly tied to mountain ranges. They do need those colder and wetter climates. Let's see. Okay, so these photos here now represent pika habitat. And so on the left-hand side here, we can see that there's quite a bit of large broken rock, and there's a lot of it. So pikas prefer to live in these broken talus patches, this broken rock. And they do this because they need to get away from kind of that heat from the summer, as well as from predators. And so they occupy these rock piles to really escape both predators and high temperatures. On the right-hand side is a site that was actually extirpated, so pikas no longer live there. And so this is a warm, dry, low elevation site here. One second, I have a dog chewing something loudly here. Sorry about that. And so on the left-hand side, there's pikas everywhere. They like that really cold, wet climate. On the right-hand side, much warmer, drier. Pikas no longer live there, but we found lots of evidence that pikas used to be there. And so how do pikas really experience climate? And so these are from two different studies. The figure on the left-hand side, they used these little temperature sensors and they put them within the talus. These temperature loggers take temperatures every hour. And so that red line shows kind of the shallow data just within maybe a couple inches, maybe a foot into the talus, whereas the blue figure, the blue dots in line here represent the temperatures really deep down into the rocks. And so this is actually from a site in Colorado in July. And so as you can see, when you're kind of on the surface of the talus or you're not very deep into the talus, temperatures seem to fluctuate quite a bit throughout the day. They get really, really warm in the late afternoon and then they cool down late into the evening. However, if you're really deep in that talus, you can see that those temperatures are essentially flatlining. Temperatures do not fluctuate throughout the day. They remain relatively stable if you get really deep down. And so pikas, this really shows that they prefer to get into those deeper interstices, these gaps between the rocks, because it allows them to escape those really high temperatures that might prove fatal to them otherwise. The figures on the right show a high elevation and low elevation sites. The high elevation is actually the one on the bottom. The low elevation site is the one on the top. And so these are, again, temperature loggers, but throughout the year. And so as you can see on the bottom, which is the high elevation site, we see these random flat lines going across in winter and late winter, early spring. And so what those actually represent is when there's a sufficient snowpack, the snow actually holds the temperature at about 0 for months at a time. However, at the low elevation site, this part of the Great Basin did not receive a lot of snow. And so they didn't see that flatlining. They didn't get enough snow to really stop these temperature fluctuations. And so this really kind of exemplifies how important snowpack is in thermoregulation for pikas. And the left-hand figure really just shows why they kind of occupy these talus patches, how it helps them escape these temperature fluctuations that other species might experience. And so this is another study here. This is not my work. This is work from Jennifer Wilkening. So this is some work from Colorado where they found that this, the plots on the left both represent temperature profiles. And so the blue figures, the two left-hand bars represent sites that had subtalus ice. And then the two yellow boxes there represent sites that did not have subtalus ice. And so the sites that were blue were much cooler, the sites that were yellow were much warmer. And so then that translates to the photo on the right, so the figure on the right. So these are stress hormones. So pikas appear to be a lot more stressed in that yellow bar as opposed to the blue bar. Again, the yellow bar represents an area without subtalus ice. And so subtalus ice we think is good because it helps pikas thermoregulate. If they have access to ice, they can have access to these cooler temperatures within the rocks. And so pika stress hormones appear to be directly related to temperatures within that talus interstices. It's a lot of cool different work going on, a lot of folks working on a lot of these really big questions here across the country. And so my work now, getting a little bit more, focuses primarily on pikas and distributions. How have their distributions been affected by climate change? And so this is some work out of California. They found that pikas across this region of Lake Tahoe, this is the northern part of Lake Tahoe, it's called the Pluto Triangle. Pikas actually went extinct here sometime right before 2011. So pikas used to occupy this entire region. Now they do not occupy any of it at all. There's this big, large swath of land that is completely absent of pikas. There are still pikas around other parts of Lake Tahoe, just this region between some highways here. Pikas in Termo, this is in northeastern California. This is typical Great Basin terrain here. And so as you can see, it's pretty dry looking, pretty hostile looking in general. Pikas went extinct here sometime in the 20th century. So we have records that pikas used to be here in the early 1900s. However, we've gone back and surveyed many times again and not found any pikas remaining. We're finding old evidence, things like that, but no longer are we finding pikas. So what about Zion? Pikas actually used to live in the northern part of Zion. Folks think it's way too hot, way too dry, which would be probably correct. But pikas actually went extinct here just before 2012. Folks went and surveyed here many years over. They actually slept near the talus patches, thinking maybe pikas became more nocturnal. But if anyone's ever been to the northern part of Zion, there are some lava escapes here. And pikas went extinct just before 2012. They weren't doing very well a couple years before that, and then they kind of plummeted. The unfortunate part is that there's really no probability or possibility of recolonizing because the nearest populations that are still alive are many, many miles north. So what about New Mexico, the Cruces Basin here? They went extinct here sometime in recent decades. Again, we surveyed this entire wilderness area and we're not finding pikas anywhere. Every single patch within this wilderness area is no longer occupied. And so, all right, enough of the bad news here. We'll get into a little bit of positive news here, but the Tetons, Eric Beaver with the USGS has surveyed quite extensively throughout this national park here. As you can see, the photo on the right, or the figure on the right, shows all the different patches that they've surveyed so far. All the little dots represent different patches. You can see there's those 3 red X's. Those are the only 3 sites that they have found so far out of hundreds that are not occupied. And so in the Tetons, they're doing incredibly well. It's just right around 100% occupancy. I believe it's 97 point something or 98 point something percent occupancy. So the Tetons appear to be just the perfect climate for pikas. They are doing really, really well there. They're occupying every possible ounce of habitat across the region. If you go hiking there and you go to any rock patch, you'll basically find them there. And so they are doing well in some areas. They also appear to be doing well in Canada. And so it's not all bad news. I'm not here to kind of make it sound like bad news, but my work focuses really on these distributional shifts. Where are they going extinct? And so for my work, the 2 primary research questions that were really driving this research were, have upslope retractions occurred in the Northern Rocky Mountains? So Montana, Idaho, have pikas begun shifting upslope? If so, by how much? And what best predicts how far they've shifted upslope? The second question was, what climatic variables best explain the shifts in where pikas live now versus where they used to live? Are high temperatures kind of responsible for extinctions, or maybe is it low precipitation, or is it humidity, or some other factor here? And so I really wanted to dig into, in Montana, Idaho, what's going on? Are they responding to climate change already, or are they doing just fine like they are in the Tetons? And so what's going on here? So to do this, we create all these different models. I'm assuming that this Zoom bar doesn't show up in your guys' window, but just in case, I'll move it out of the way. So what we do is we create all these different models and we kind of compete them all against each other. So we have different variables that respond to different aspects of physiological stress for pikas. So the number of days above 26 degrees, which is right around 80 degrees Fahrenheit. So the more days above that temperature threshold, we assume that that's going to have a negative effect on pikas. Actually, evapotranspiration. If you have more evapotranspiration, it's going to be a drier site, most likely. That's a little bit more complicated, but and the mean winter temperature, for example, could deal with cold stress. And so we have all these different metrics that we measure. We extract from different models, from different climate models, and then we kind of compete them all against each other to see who best predicts differences in where pikas are and where pikas used to be. We did the same thing for abundance, but I'm not going to talk about that here because that's a little bit more complicated. It takes a lot more time to explain, but we do the same thing for both abundance and occupancy. And we also look at some other factors too. Is it maybe a non-climate signal? Could it be solar insolation? Could it be the presence of cattle grazing? Could that have a negative effect on pikas? Could it just be the patch size, the number of home ranges? And so we look at all these different things, compete them against one another, and it helps us really understand what aspects of climate are driving changes. Let's see. There we go. Okay, so when we go out there, how do we know if a pike is there or not? And so first of all, most obviously, we can see them. You can see pikas running around. Although they are pretty camouflaged, they make themselves pretty visible. So we see them running, we see them squeaking. I guess I should say we hear them squeaking. And so we can see them, we can hear them, but we can also know that they're there indirectly, and we can find their hay piles. And so the left-hand photo, there's a really large hay pile. And so they store all this food for winter because they don't hibernate. And so what this guy is doing is builds up a bunch of hay, consumes it all winter long while it's underneath the snow, and then can survive the winter that way. They just cannot build up enough fat to hibernate like marmots can. And the right-hand side, within these rocks, you can actually see kind of in the center of the photo, a little bit to the left of center, there's some grass within the rocks. That's actually a full hay pile, just really, really buried in there. And so we can tell that pikas are currently there based on whether we see them or hear them, or if we find their hay piles that look really fresh. So how do we know that pikas used to be there, maybe? Maybe they're not there anymore. And so is there any way that we can tell that an animal used to be there? This is really hard for most animals. Most animals do not leave behind evidences. So how do we know that a mountain lion used to be in my backyard 200 years ago? There's really no way you can tell that. But with pikas, they leave behind these evidences that last a really long time within the talus patches. And so on the left-hand side here, we see a really old hay pile. This was in Idaho. Very, very old hay pile. Pikas have not been here in probably at least a decade, maybe a couple decades. And so this grass lasts on the landscape, and we can go into that grass. And on the photo on the right, you can see all those fecal pellets. In the center, that is also a fecal pellet with some urine dried onto that rock there. And so we can tell that pikas used to be there based on the presence of old hay piles, old urine stains, and old fecal pellets. We can collect these, we can carbon date them, we can do all sorts of things. But it's a really cool species to work with because most animals, you cannot tell that they used to be there. Pikas are one of the few exceptions. So getting into my study region a little bit more here. So where we're located is right approximately the species range center. And so pikas extend from down in New Mexico up into Canada. And so where the red circle is on the right-hand figure, that shows the mountain ranges primarily that I worked in. There was 4 of them. This region has never been studied for pikas before. And so we figured it was a great opportunity to get a little bit more information about pikas. And so we also were able to run these gradients of really low elevation to really high elevation talus patches that we could survey. So we could survey talus patches down at 5,000, 6,000 feet, all the way up to 12,000 feet or 11,000 feet. So we have this large elevational gradient of habitat that pikas could occupy. And so it was a great study region to test some of our questions. Colorado has the same situation. I'll get into that a little bit more later. But, and finally, pikas are a species of conservation concern. Essentially, it's kind of like a state level endangered listing almost, you can think about it. They're only not listed in 2 different states, and that is going to be in Montana and Idaho. Funny enough, after this research, both states are actually considering listing pikas now as species of conservation concern. So it may soon be 11 out of 11 states. So getting a little bit more specifically into the study region that we were working, these 4 mountain ranges. And so I've labeled them, and they all have black lines going through them on the left-hand most figure there. So the Beaverheads, the Tobacco Root Mountains right by Bozeman, the Italian Peaks, and the Lemi Range. So these 4 different mountain ranges run somewhat in a north to south fashion. And what we did, you can kind of see it a little bit better on the middle figure there, is that we surveyed 1 watershed on the west side and 1 watershed on the east side in multiple different, what we call transects. And so each transect up and over a mountain is 2 different watersheds that are connected. And so we surveyed 12 different patches within each watershed. And so we did this to try to get at, originally we tried to get at this rain shadow effect, which turns out there really isn't a rain shadow whatsoever in the Northern Rockies. It's just too far inland. But the study design really allowed us to get at that gradient of low to high elevation surveys. And so the right-hand most figure now shows the yellow is the low elevation, goes up to red, and then goes up to white, which is the high elevation. And so each of those polygons is a different talus patch. And so as you can see, the orange patches are the extirpated sites that pikas no longer occupy. The green is where pikas still currently are. And so those sites where they currently are primarily focused in the higher elevation areas. That one site at the highest elevation, we think it may be too windy, something else is going on here. But primarily, pikas are not doing well at the lower elevation sites. They're no longer occupying the low sites. However, they are occupying the higher sites. This is kind of just getting into the sampling design here. And so This is just that same mountain range, actually. This is the Tobacco Roots near Bozeman, Montana. Each of these colors on this map represents a different site that we surveyed. So green represents all the occupied patches. Orange represents patches that pikas used to occupy, but no longer occupied today. And then red are a couple of the patches where we found no pika evidence at all. And so in this mountain range, we got pretty high coverage. As you can see, we surveyed almost all the watersheds within this mountain range. So it's one of the smaller ones that we worked with. But overall, you can see this, we really did these watershed-based transects to get at how far have pikas shifted upslope, have they shifted upslope in every watershed, what's going on there. And so let's see if this will actually play. Okay, so it's a little bit jumpy at the beginning here, so I apologize. But this is a watershed in Idaho where you can see these polygons on the landscape, these oranges where pikas used to live, but they no longer live. And so these low elevations are primarily just all extirpated sites. But as you get to the mid and high elevations, they turn green. So we have pikas towards the higher elevations. So let this run through here. And so once you get up above a certain elevation, basically every single patch has been occupied. And so you just have to get past some sort of temperature threshold, some sort of other threshold, and pikas appear to love it. But below that threshold, pikas are no longer occupying these regions. So this is just kind of a glimpse into the results here, but this is kind of the study design still continued, how we did low to high elevation transects. Oops, okay, skipping to the next slide. Hopping into our mountain ranges. So this is a photo of the Beaverhead Mountains. This is a very wet and cold mountain range. As you can see, just filled with conifers, there's lots of snow. This photo was in June. This is the Italian Peaks. The Italian Peaks are kind of a unique mountain range in that they're primarily sagebrush and grasslands. They do go up to about 11,000 feet. However, they're still really, they're not forested. They're not heavily forested in a lot of areas. And there's a lot of grazing going on here. Anyway, the Lemi Range, this is your typical Northern Rockies mountain range. You got a lot of limestone, you have a ton of talus, lots of possible habitat for pikas. And we see these meadows in the forefields that pikas really enjoy. Overall, it's a really dry mountain range though still, compared to some other areas of the Rockies. And then the fourth mountain range is the Tobacco Root Mountains, the ones I was previously mentioning. And so this is your typical, this is more so, I guess, the typical mountain range in the Northern Rockies. We have these mid elevations are dominated by conifers. The low elevations outside of this picture are going to be sagebrush and grasslands. And then the really high elevations that you can see kind of in the back there are going to be your alpine tundra, these really cold areas that have permafrost all year long. You guys have lots of that in Colorado. And so what do some of these actually patches look like close up? And so this is actually one site on the right-hand side where there were pikas just occupying right next to a river. Right next to a hiking trail. They didn't care whatsoever that we were there. There's another patch, tons of pikas here. It was snowing actually during our surveys. So it was a pretty bad time, but pikas really enjoyed the cold. They did not go into hiding. They were still just running around everywhere. And so they didn't mind the snow whatsoever. This is a site in the Beaverhead Mountains. There's actually a black bear down just below us there. You can see kind of in the lower part of the meadow there. And this is probably our worst sites to get to. We had to climb down about 1,500 foot cliffs just to get to these patches down at the bottom that you can kind of see there. They're really down. There's one actually down deeper in the canyon. And so these are really hot, dry sites that no longer have pikas. And then this is a site in Idaho. This is a rock glacier. So this is a feature that has a glacier essentially hidden underneath all these rocks on the right-hand side. And so there are pikas everywhere. They really love the fact that there was this subtalus ice present to keep them cooler. And so getting into the results, what do we find? How many patches were actually occupied by pikas? And so we found that about 6 out of 10 sites were still occupied by pikas, which might seem to be good until we compare it to other regions. And so Glacier National Park, they had about 80% of patches were occupied. The Tetons found they're just below 100%. Rocky Mountain National Park has about 80 to 90% are occupied. And the Southern Rockies, another study, found about 97% of patches were occupied. And so in these 4 mountain ranges that I studied, occupancy was actually markedly lower for some reason, more comparable to areas of California and the Great Basin. And so getting into why that might be, it turns out that all of our top models that we competed against one another showed that it appeared to be acute heat stress. So this is the number of days above their upper lethal threshold that pikas can essentially deal with. So what is that maximum temperature before their body essentially just gives up? And so for pikas, that's about 80 degrees, 26 degrees Celsius, 80 degrees Fahrenheit. And so the more days above that threshold, the lower the probability that we found pikas still occupying a certain patch. Also, we found that actually evapotranspiration, AET, was important for pikas, as well as patch size. So bigger patches were good for pikas, but only if those big patches were located in really cold and wet areas. That patch can be very, very large and it would have a positive effect. But if it's in a hot, dry area, pikas still occupying it. And so out of the top 7 models that we had, pikas, acute heat stress and patch size appear to be in 6 of the top 7. And so those 2 metrics were essentially what's driving the bus, it looks like, in the Northern Rockies. Pikas really do not like the heat. They want their summers to be much cooler. It doesn't appear to be a snowfall effect. It doesn't appear to be winter temperature. It just appears to be heat stress in the summer. And so extirpated sites, on average, these sites that pikas no longer occupy, they had on average 11 more days in the summer above 26 degrees. And they're on average 1.4 to 3 degrees Celsius warmer in the summer than occupied patches. And so this is an example on the right-hand side here of a site that is no longer occupied. It looks very, very dry, looks very, very warm. And it was, of course. You can tell by the vegetation around it. But this site had not had pikas in decades. You could tell the evidence was all very, very, very old. And we actually did not find pikas in this watershed until the tippy top of the mountains. So they weren't doing well in this area. And so this is a fun figure I like to show people. So that we have abundance on the left-hand side and we have occupancy on the right-hand side. And so each of these symbols here represents a different climate metric and how abundance or occupancy is affected by that metric. So for example, on the bottom there, we have summer PPT, so summer precipitation. And so because that's right of that dotted center line on both figures, that means it has a positive effect on occupancy. And so the wetter it is in the summer, the more likely you will find pikas, and also for abundance. And so the wetter it is, the more pikas you're gonna find. And so we see that these, I guess, variable directions, so positive versus negative, are pretty consistent between both abundance and occupancy. And so we can see that these summer heat stress metrics appear to have a negative effect there to the left of the line on both occupancy and abundance. Whereas we have these winter metrics, acute cold stress, essentially things like winter temperatures, they actually have a positive effect on both occupancy and abundance. And so if I'll leave this here for a second, if there's any metrics that you're interested in, we can always come back to this figure, but like SWE doesn't have a big impact, so that's snow water equivalent. We're not really sure why snow didn't have a large positive effect as it should, but we may find that signal elsewhere. I will tell you right now that in the Tetons and Yellowstone, we have another study going right now. And in the Tetons and Yellowstone, we find that the most important variables are both winter temperature and winter snowfall. And so the importance of these predictors, the importance of these different climate variables seems to differ across different regions. And so did we find upslope retractions? How about that? So each of these gray bars represents a different watershed across these 4 different mountain ranges. And so we have the minimum elevation of the watershed up to the maximum elevation within that same watershed. And so each one of these represents a half of a transect, basically. And so when we actually want to look at occupancy, do we see primarily extirpations at low elevation sites, or do these gray bars just stay gray? So gray here represents occupied elevations of pikas within that watershed. And so I'm about to hit the trigger on a different button. I'm going to bring orange into this figure, but notice how we see primarily these low elevation sites are no longer occupied by pikas. We find that extirpations at low elevations were widespread, upslope retractions were widespread. We see in some areas pikas seem to be doing really well and they didn't retract at all. But if you actually look at the minimum elevation of those watersheds, for example, on the right-hand side of the Italian Peaks or the Lemi Range, those areas where pikas have not yet retracted, their minimum elevations are really, really high. And so they actually don't extend that low. These valleys don't extend that low. There's just no talus down low. And so where we do see the most retractions, though, appears to be where pikas, I should say where the watersheds actually dip down a lot lower. And so this is a pretty clear signal of temperature. We know that temperature across elevations is very tightly correlated with elevation, I should say. And there's actually, oh, I forgot to include it. So in the Lemi, as you can see, this one watershed here, the third one from the left is actually full orange. That watershed is completely extinct of pikas now. And so there's no longer any pikas. This right-hand figure here kind of shows kind of what is going on with this figure. I already explained it though, so for the most part, we're good to go with that. But as we can see, overall, there's a lot of orange. There's a lot of upslope retractions going on across the region. 44 out of 64 watersheds in total ended up retracting upslope already. And so that's about 70%. And the mean retraction upslope was about 277 meters. And so quite a bit. Here's another quick little video here. And so the red here represents the minimum elevation that pikas used to occupy in the Beaverhead Mountains. The green is the current minimum elevation that pikas now occupy. And so pikas used to extend from the peak all the way down to the red line, but now they extend from the peak only to the green line. So as you can see, they've shifted up. They've lost about half of their total elevational band across this mountain range. This is 3 different watersheds here. I posted a link here. It's just also on my website. Oops. All right. So how about pikas in New Mexico? Go back. Sorry, I got a dog whining in the background. So we're just wrapping up some work in New Mexico. And so I'm going to just present very, very preliminary data here. We don't have the full results yet. But why did we work in New Mexico in the first place? There weren't really any statewide efforts yet to survey for pikas. If we look at where there are historical records that pikas exist in the state, they're very, very high elevation biased. And so people had went and found them back in the day, back in the 1800s, back in the 1900s, but they're all at like 11,000, 12,000 feet. And so we decided to go survey as much of northern New Mexico as we possibly could. And so in total, we surveyed 570 patches across 7 different years, from 2015 to 2021. And so the oldest place that we found old evidence was 7,500. And so that's actually pretty low. We expected the minimum elevation of old occupancy to be quite a bit higher. But now pikas are primarily only still occupying the really highest elevations across the state, as well as the like Bandelier and Baez caldera. And so in total, statewide, as of 2021, about 55% of patches were already extirpated. So less than half of pika populations are still in existence today. Excuse me. And then if we want to look at populations below 3,100 meters, about 72% of those are extirpated. And so we really see that these extirpations are primarily below 10,000 feet. However, there are some high elevation extirpations going on in different regions. Like I said, we're still running the results. We ask people do not cite this. I'm not too worried about that here, but we're still getting into this. We plan to publish this the next year or two. But overall, it appears that pikas are not doing too well in New Mexico either. Just one note, I guess, in the top right figure or the top right photo there, that's the Baez caldera National Monument in northern New Mexico. That area actually has pikas throughout it. It actually just burned up a couple days ago again. So as you can see, there's a lot of downfall there. Somehow that's still burned for a second time since 2011. And so that fire is still going in New Mexico. We have other sites in the eastern part of New Mexico that are still burning. And so we're not entirely sure how pikas are going to respond to these wildfires. We don't suspect it'll be overly positive, but pikas cannot live and just stay within these rock interstices while a fire goes over them, and they can survive the fires directly. It's what happens after the fire that we're worried about. Are they going to have enough forage to be able to consume and build their hay piles before winter comes along if a fire just burned up all their food? That's a bit more of the concern as opposed to the fire directly killing them. We do believe that they do withstand fires probably pretty well because temperatures don't increase that much if they stay within the rock interstices as the fire burns over them. And so what are the kind of take-home messages here? And so in the Northern Rockies, in Montana, Idaho, in these 4 mountain ranges at least, we found that 1 out of 3 populations is already gone, which is much higher than what we find elsewhere in their range. And then the culprit of all of this appears to be rising temperatures, and those rising temperatures specifically in the summertime. They don't like these days of really high temperatures. However, once we get to the higher elevations where temperatures are cooler and conditions are a bit wetter, we find that pikas are essentially everywhere. They're doing really, really well at these high elevations. It appears to be the same scenario in Colorado. Once you get above a certain elevation, they're doing really well. However, below those elevations, they might not be doing so well. And so in general, what we're finding across the entire species range across the entire Western US and Canada, the species generally does not do well under hot and dry conditions. That goes for New Mexico, that goes for Nevada, that goes for Montana and Idaho. They really do not like the hot and dry conditions, which is unfortunate because with climate change, we do expect to see a lot drier and warmer conditions moving forward. In Yellowstone Tetons, as I mentioned, we're finding that it's snowfall. And so snowfall has a positive effect on them. But with climate change, we're also seeing a decrease in snowfall. And so that's going to have a negative effect on pikas moving forward as well. And so long-term monitoring efforts, such as those by Rocky Mountain Wild and citizen scientists across the state, are really great because climate change is acting as somewhat of a natural experiment. We can't just go out and heat up these individuals until they die. That's not ethical, of course. And so by doing these long-term monitoring of different sites using citizen scientists and other folks like yourselves, is really fantastic because it gives us this long-term data to see what aspects of climate are really changing things. And so to wrap up, New Mexico also, they are just showing these rapid declines in regional extirpations. Even among years, if we say sort of in 2016 to 2019, we're seeing many more extirpations than we are recolonization. So pikas are being lost faster than they can recolonize habitats. And Colorado could prove to be a really particularly important state for the two subspecies. They have the Northern Rockies subspecies and the Southern Rockies subspecies in Colorado, and they actually meet in Rocky Mountain National Park. There's a hybridization zone going on there. And so Colorado, assuming that pikas might be able to do well with climate change in the future in the state, could be a crucial state for the species persistence in the long term. And so my work actually going into Colorado in 2022 here this summer is going to try to help expand upon the work from other folks to help assess how pikas are doing across the state and across the Southern Rockies more broadly. And so I will be doing the same thing here. I will be doing these elevational transects, surveying many different watersheds across Colorado and looking at where pikas are and where pikas used to be to really understand what aspects of climate might be driving their extirpations at low elevations. In Colorado, it could be snow, it could be summer temperatures, it could be winter temperatures, it could be anything. And so the goal of my research this upcoming summer is going to be to figure out what's going on statewide as well as in the surrounding states in the Southern Rockies. And so with that said, I'd like to thank everybody. I could not have done this myself. This is part of my graduate committee there on the left, my field technicians who helped survey. In my study, we had 760 sites that we surveyed across the mountain ranges. And so this is a massive sampling effort. And so I could not have done it without all these wonderful folks with me. This paper was published in this journal on the right-hand side. They actually chose a pika photo for the cover because who doesn't want to look at a cute little pika, of course. And then, of course, all of our funders as well, the American Alpine Club down in Colorado there, Montana State, the National Science Foundation, the American Society of Mammalogists, all these different folks help support this wonderful research. And so I will wrap it up with that. And so I'm sure we'll have time for questions, I think, in a little bit. So I will hand it back off to Chris.
Okay, do we want to do questions right away for your presentation, or were you thinking Megan goes first?
Oh, I don't care at all. I can do either one. So it's totally up to you guys.
I'll go ahead and do my presentation really quick because it's just a quick introduction to the carbon offset program, and I'll try to go through it fast. That way we have plenty of time for questions. Does that sound good?
Sounds perfect.
Let me share my screen here. Are you guys seeing my screen now?
Yes.
Okay, and then, uh-oh, I don't know what I just did. 1 second here. Okay, are you seeing my screen now still?
Yep.
Okay, great. I'm sure a lot of you watched Peter's presentation and like me, felt concerned about what's going to happen with pikas and climate change. And so I wanted to talk to you about some concrete action that you guys can take to try to help fight climate change and protect pikas and prairies at the same time. I already introduced myself at the beginning, so I'll skip over that. So there's two different ways you can help pikas here in Colorado. One is to contribute to the Colorado Carbon Offset Partnership. And the second is to join the Colorado Pika Project as a community scientist. So the Colorado Carbon Offset Partnership is aimed at combating the climate crisis and securing a future for Colorado's wildlife. It's a partnership of Rocky Mountain Wild, the Southern Plains Land Trust, and the Colorado Pika Project. And so, you know, there's a few different ways we can really tackle climate change, and all of you are familiar with the concept of a carbon footprint. Everybody has a carbon footprint. And a really good way to help pikas and other wildlife is to reduce emissions to slow down climate change. And I think it's really important with wildlife to understand that every fraction of a degree matters. So there are some models done in Colorado that showed that the slower climate change happened, the less warming we had, the less likely we would be to lose pikas from parts of their range by 2100. So you can use a carbon calculator and then pledge to reduce your carbon footprint. And then the Colorado Carbon Offset Partnership is set up so that you can donate to offset the portion of your carbon footprint that you aren't able to reduce, because it can be hard to reduce it completely. And so the partnership will use your donations to do three things. The first is to fight climate change by protecting carbon sequestering prairie. A really great way to slow climate change is by conserving carbon sinks, which are nature's reservoirs for absorbing and storing carbon. And prairies are actually a really stable and long-term carbon sink that can help address the climate crisis. So they're almost like the inverse of grasslands. They have very deep roots that go way down into the soil that store a lot of carbon. And they're stable because when the prairies burn, unlike forests, they grow back really fast. The roots can stay intact, and so they can keep sequestering carbon over time. And so 80% of each donation to the partnership goes to an organization called the Southern Plains Land Trust that conserves intact carbon sequestering grasslands. And they already own and hold easements over 38,000 acres of grassland preserves in Southeast Colorado that sequester around 15,000 metric tons of carbon annually. And they're operated through the Climate Action Reserve. 20% of each donation to the partnership goes to fund solutions to help pikas and other wildlife cope with climate change. So, you know, we all know that climate change is a global problem, and it's going to take some time, even if we do everything we can, to reach the point where greenhouse gas emissions stop climbing and start declining. And in the meantime, we really need to help pikas and other climate sensitive wildlife cope with the effects of climate change. And one way to do that is to really make sure to address all of the other threats to the species, because the bigger the population is and the less other threats that the species faces, the more likely it is that those populations that are in, you know, good locations, like the ones at high elevations that Peter was talking about that are persisting, the more likely it is that those populations can survive. And so with pikas, you know, there are some other emerging threats, like a disease that affects rabbits called rabbit hemorrhagic disease virus. And so this will create a fund to help us address threats like that. The third thing that your donations do is provide a permanent refuge for wildlife. Southern Plains Land Trust uses every penny that's donated to them to buy additional acreage of prairie. And all of that prairie, in addition to sequestering carbon, is managed as a permanent refuge for prairie wildlife. They've got everything from bison to monarch butterflies to, you know, porcupines and elk. And it's just a really amazing wildlife refuge. They're working on getting ready to reintroduce endangered black-footed ferrets. So you're also permanently protecting habitat from wildlife by donating. To learn more about this program, you can go to pikapartners.org/carbon, and you'll find resources there to learn more about the project and the partnership, to calculate your carbon footprint and figure out how much you should donate to offset it, and all of those kinds of things. So check that out. And I think it's really important to note that it can be hard to afford to offset your whole carbon footprint, but any donation really helps. And a lot of small donations can add up to conserve a lot of prairie and sequester a lot of carbon. The second way there are some other ways you can help. You can spread the word about the partnership. You can organize a fundraiser for the partnership, and there's information about how to do that on the website. You can also take action to protect carbon sinks at www.climateforest.org. And there you can ask the Biden administration to protect old growth forests on public land that are also really great carbon sinks. And then the last thing you can do if you haven't already is to join the Colorado Pika Project. You can become a Colorado Pika Project community scientist. Our volunteers hike up into the Alpine and do surveys for Pika and help collect the kind of data that Peter was talking about in his presentation to really track how pikas are responding to climate change and come up with solutions to conserve them over time. To learn about that, go to pikapartners.org/involved. You need to attend a classroom and a field training, and these are the dates of the field trainings. The classroom training you can do at any time, just online. And so you can go to our website and sign up if you're interested in that. We're also getting close to being ready to release a new app called Pika Patrol, and you can use that anywhere in Colorado when you're recreating to record pika observations, and that's also really useful data. We anticipate that app will be out in July. It's been tested by our volunteers, and we're doing a little bit of updating and fixing things that volunteers identified that needed to be fixed. And then we're hoping to release it after that. And for that, you don't really need any training. All the information you need to participate is on our website and in the app. And then the Carbon Offset Partnership is a partnership of Rocky Mountain Wild and Southern Plains Land Trust and the Colorado Pika Project. And then the Colorado Pika Project is a partnership of Rocky Mountain Wild and Denver Zoo. And with that, I'll and I want to acknowledge all the photographers who contributed to this. You can see the credits there. And I think now we can do questions. So I'll stop sharing here.
Do you mind if I run through the questions in the chat here real quick?
Sure.
So it looks like Robin, I think that's the first one here. And so why do the hay piles over a decade old not decompose? Too dry? Yes, exactly. And so where we see old hay piles in really high wet areas, they don't last nearly as long. However, in places like New Mexico and lower elevations of Idaho and Montana, where conditions don't get a lot of snowfall, they don't get a lot of rain, these hay piles can last a long time. In addition to that though, talus acts as a natural buffer against the elements. And so if your hay pile is buried really deep within the rocks, it's going to shelter you from the snow and the rain. And so that's going to help the vegetation not decompose either. And so they can last for decades. In the Great Basin, they last even longer than that. They found some that are up to, I believe, 100 years old, potentially even older. They can get that from carbon dating, some of the fecal pellets within them. But yes, that's a great question. For the most part, where it's wetter and cooler, they are going to decompose much faster. Or if they're on the surface, they're typically going to decompose faster. But where conditions are hotter and drier, they will last quite a bit longer. And so, yeah, hoping that answers that question. And then your second question there. So where are your project areas in Colorado for 2022? So that is, it's really hard to describe, but it's essentially statewide. Across the entire state, in each mountain range, there's several different sites. There's a bit of an emphasis in the Boulder County area, so the Front Range. And so there's quite a few transects going from essentially the Boulder area up to the Continental Divide there. And there is also 2 transects in New Mexico, there's 2 in Utah, and then there's 4 in Wyoming. And so the goal is to try to cover as much ground as I possibly can across the entire state. We, of course, are limited on man hours, how many miles I can actually hike, but the goal is to do about 20 to 30, potentially even more transects across the state to really get a broad picture. From that orange and gray bar figure that you saw, there's a lot of diversity in whether or not pike is retracted in different watersheds. And so if we were to just survey a single watershed in a retracted, say 2,000 feet, that would be like, oh my gosh, like it's a terrible signal. But we may survey a bunch of other watersheds and it may not be actually that bad, or it could be worse. And so I should say just serving one watershed is not enough. We want to serve as many as we possibly can. And so the goal is to cover as much of Western Colorado as I possibly can across, I have about 80 days to do it. And so I should be able to get around 30, potentially slightly even more than that done across each of the mountain ranges. So Brittany asked the question, is there a common elevation across states and mountain ranges that you're seeing a line separating active populations and extirpated sites? Yes. So we call that, what do we call it? The Pika relevant elevation, I think. And so as you move more northwards, pikas can occupy lower elevations. In the Northern Rockies, in Montana, I have found that that separating line is right around 7,500 feet. And so any populations below that are almost guaranteed to be extirpated. Sites above that are typically occupied. However, you go to New Mexico, that elevation goes around, it's just below 10,000 feet. And as you go northwards in Canada, there is no minimum elevation. Pikas are everywhere up in Canada. And so that elevation does depend where you are at latitudinal wise in their range. And that goes for other species as well. But in Montana, Idaho, it's 3,500. The goal is to figure out what that is in Colorado here. It's going to be quite a bit higher. It's going to be probably between 8,000 and probably 9,005. And so we'll know that answer for the Colorado area next year, hopefully. And Brittany also asked, do you have a concrete date in July for when Pika, oh, never mind, that's a question for you, Megan. Do you have a concrete date in July for when the Pika Patrol app will be live?
We're aiming for July 15th, but our app developer is a volunteer and he's got a full-time job and a brand new baby. And so we'll see how it goes. But that's our goal. And I think Chris put a link in the chat where you can sign up to get emailed as soon as it's out.
Perfect. And then it looks like that's it. So yeah, I'm happy to answer any other questions that folks have. I see Robin's comment about coming to the western slope of Colorado. Absolutely. If anybody is in the area, I would be more than happy to take folks out. I would be happy to also learn from you guys. Any information you guys have, I would love to learn. There's nothing better than local knowledge. And so I would be happy to chat with folks. But also I'm happy to take any other questions that folks may have as well today.
Chris, do you have questions that people sent in advance?
Yeah, well, you answered the question about the app. Sully asked, what steps are parks taking to protect pikas and their habitats?
I could talk about Rocky Mountain National Park, and then maybe Peter, if you have other thoughts, you could talk about other parks.
Sure.
So here in Colorado, Rocky Mountain National Park is about to make pikas a focal species for management. I don't think that's final yet, but they're working on that. And they're planning to basically, most of the pika habitat in the park is already totally protected from development and from most other impacts. The exceptions to that are kind of human use, so like trampling of the alpine by tons of people. And then there's some concern about rabbit hemorrhagic disease virus, which is that virus I mentioned that affects rabbits and is spreading across Western North America. We're not sure yet if it affects pikas, but if it does, it could be really a huge problem. So the park is basically looking at how to address those two threats. So making sure that good habitat is protected from the tundra being trampled, and then making sure that pikas don't get rabbit hemorrhagic disease virus if they are susceptible to it. And then they're also supporting the Colorado Pika Project's research, and that research is really aimed at coming up with other ways to help pika be resilient to climate change. So, and that's a hard challenge to tackle, and that's part of why we started the Carbon Offset Project, because really to protect pikas, we need to slow down climate change. And so that's one way. And then I think the other way is to try to look at how to make them more resilient. Peter, do you know of other parks doing things?
I'm not the best person to answer this question, I will admit. From my understanding, there's really not much going on. A lot of national parks across the Western United States are located at higher elevations. So Rocky Mountain is a perfect example of that. And so a lot of the national park pikas appear to be doing pretty well. We also see that, of course, in the Tetons where they're everywhere. Bandelier National Monument is one in New Mexico, as well as the Valles Caldera. They both butt up right against each other in Los Alamos area there. So funny enough that because they have that fire burning through right now, it's actually of interest to us. But they have agreed, because they only have a couple pikas left in Bandelier National Monument, that they plan, when they do prescribed fires across the park, they plan to do about a 50-meter perimeter around each talus patch. So that way you're not burning up the pika's food. And so that's a really great strategy, we believe, because there's not much you can do for pikas in general. And this is why we think that folks are not probably doing a lot to save pikas, quote unquote, save them, because there's not a lot that we can do. But when it comes to prescribed burns, that is one solution. Don't burn up the food right next to the patch where they're likely going to graze. Again, Tetons are doing great. Yellowstone, they're not doing so great. Yellowstone does not have any management ideas quite yet. They're not doing anything yet. Lassen, Yosemite, and Kings Canyon are not doing anything yet. Most places are not doing anything quite yet. And that's because a lot of these areas, like I said, are located in higher elevation areas where pikas appear to be doing well. Other areas where they're not doing so well are typically outside of national parks or any sort of management areas. So the Forest Service generally is not doing a lot. The state wildlife agencies are not oftentimes doing a lot. There's just not much they can do. And this isn't to blame anybody. The best thing that we can do is really to provide them with a cooler, wetter habitat, but there's only so many ways that we can do that. And so it's a really tough challenge for managers to face. But there's still a lot of questions we also don't know. Like, are pikas negatively affected by hiking trail locations? It appears that they're not, but we don't know yet. Are they affected by roads going next to them, or are they affected by ski slopes, things like that? There's a lot of things we just don't know yet. And so a lot of these things will be studied over the next couple of years by different folks. And so hopefully we'll have some more answers coming up for what managers can do. But as of right now, there's not a lot going on because there's not much they can do yet. So sorry that that's not more of a positive message.
Those are the questions we had entered during registration. Does anyone want to come on mic and ask any questions they might have? Going once? Okay, well, thank you so much, Peter, for being with us today and sharing all your research. And thank you everyone for attending. I'm going to drop a link in the chat to the rest of our events for Colorado Endangered Species Week in case you want to check out any more of the fun things going on. And we will be sending out an email with the recording in case you missed any part of that. And I'll also drop the chat and the transcript. We had a request for Spanish translation, so I will go ahead and drop that in the email as well. And if you think of anything after the fact, we're always here, so you can go ahead and shoot us an email and we'll try to get your questions answered. But thanks everyone for joining us, and have a good rest of your Colorado Endangered Species Week.
Thanks, everybody. Thanks, Peter.
Yeah.